Hello guys, so welcome back. So today we will discuss the ISI MStat 17 it should be, I'm so sorry. Problem 7, the subjective part. So the problem can be easily solved if you know the concepts of simple linear regression, the theory of least squares, how to estimate the parameters from the theory of least squares, and then calculating the expectation and the MAC, the variance, okay? So if you are quite accustomed and very comfortable in this, then this problem is perfect for you to try. So let's see the problem now. The problem is really, it can seem like multivariate regression, but actually it is simple linear regression. So here, if you see, there xi y1 and corresponding x1i and x2i. So it seems like multiple variates, but essentially it's a simple linear regression because I mean not simple linear regression, but the ideas of simple linear regression will be essentially important over here. Let's see. So first of all, we have these parameters beta1, beta2, and we have this the corresponding xi data, okay, x data. And as you know, the corresponding errors follow the mean with mean 0 and they're uncorrelated and their variance is sigma square. And obviously we will estimate beta 1 hat and beta 2 hat, but here the problem rests on the fact that we're estimating beta 1 hat by not minimizing the actual least square. Okay, what is the actual least square? The actual least square will be summation of yi minus beta 1 x1i minus beta 2 x2i whole square. Okay, but here what we are doing is they're sort of incorrectly they are minimizing this least square. Sort of they're assuming the model yi is equal to only this part plus epsilon I, and they're minimizing it and they're getting beta 1 hat. So now they want to estimate that how good is the model for this. So if we estimate beta 1 hat by this, then sort of it's asking that what is the means for error of beta 1 hat with respect to the actual model and the bias also. Okay? How good this beta 1 hat is. Okay, so that's the main aim now. So let's clear all this stuff and let's move on to the solution part. Perfect. So what we have, let's try to understand. We have y1 is equal to beta 1 x1i plus beta 2 x2i plus epsilon I, where epsilon I follows some normal, not normal, but something expectation 0 and sigma square, and they're independent, uncorrelated rather, which is only important for the regression part, linear regression part. So first step is that first step beta 1 is estimated by mean square, like by least square method of by minimizing what? Summation of yi minus beta 1 x1i whole square, 1 from I from 1 to n. So let's minimize this first. So let's calculate it. So if we minimize it, that means we will do this summation. Let's call it L beta 1. We will do L beta 1 by like d of L beta 1 by d beta equal to 0, which will sort of imply that summation of 1 I from 1 to n x1i times y1 minus beta 1 x1i is equal to 0, which will sort of imply that beta 1 hat, if you solve this, it will come out that beta 1 hat is what? The xi yi term will be there, so summation of x1i yi I from 1 to n by summation of x1i whole square. Okay, so this is the thing we get as the estimate of beta 1 hat. So this is almost the first part of the problem where you estimate the beta 1 hat by minimizing the least square. Okay, the next part of the problem goes as finding the expectation. So let's create notation rather, that summation of ai bi I from 1 to n, let's call it sa comma b. Okay, small sa comma s of a comma b. So what we have got beta 1 hat, it's summation of I, what we have got x1i comma into yi by summation of x1I times x1I. Essentially, it's s of x1 comma y and by s of x1 comma x1. Okay, so this is the beta 1 hat we got. So now we also know that yi is the what? Expectation of yi, since the epsilon I, expectation of epsilon I is 0, by the model of yi, it's beta 1 x1I plus beta 2 x2I, because the expectation of this is equal to 0. So it's this. So now if you want to find expectation of beta 1 hat, it's actually a function of y, right? Some linear summation, like linear combination of y. So it's very easy. Since expectation is linear, what we will do? It's summation of x1I, yi by s x1 x1. It's a constant. It's expectation of this. If you take expectation of this, it's summation of x1I. It's a constant expectation of yi by s x1 comma x1. So you get that it's equal to summation of, okay, let's not write here. Let's write here. It's equal to summation of x1I. Let's replace expectation of this. It's beta 1 x1I plus beta 2 x2I by s of x1 x1. What do you get from here? Observe, you get expectation of x beta 1 common, xi by s of x1 x1 plus beta 2 s of x1 comma x2 by s of x1 comma x1. Observe that this is equal to this, right, by the definition. So therefore what we get that expectation of, we got the following results, that beta 1 hat is equal to s of x1 comma y by s of x1 comma x1. Expectation of beta 1 hat we got to be what? Beta 1 plus beta 2, okay, s of x1 comma x2 by s of x1 comma x1. So observe that if beta not equal to 0, then expectation will be beta 1. That's actual linear, restricted linear, simple linear regression. Okay. So therefore, this is the extra bias that is coming up over here. So therefore, it implies that bias of beta 1 hat is equal to what? It's equal to beta 2 x1 x2 by x1 x1. So it's really important because the next part is calculating the MAC. Okay. So let's try to calculate the MAC now. Very easy problem, guys. Just simple basic knowledge of it. Okay, I'm sure you will be like, it will be really easy for you to find the MAC. To find the MAC, so the MAC of any estimate, T is equal to bias of T whole square plus variance of T. So this is actually the idea of also underfitting and overfitting. So if you do and go into a bit of more understanding of the model and the algorithm and why this is underfitting and overfitting, I will create a video for you surely. But let's not go into that details now. Let's go into calculating this. Therefore, you know this beta 1 hat. So you just need to know the variance of beta 1 hat now, right? So let's calculate the variance. The next journey is to calculate the variance of beta 1 hat. It will be simple like that, the previous one. So the next term is now carry. So let's write it down. Beta 1 is equal to what? Summation of x1I yi by s x1 x1, right? So we observe it's some simple summation of the linear combination of yi, and yi's are independent, right? They're uncorrelated, independent, right? Because epsilon's i's are independent. So therefore variance of beta 1 hat will be what? Summation of, right? Summation of variance of x1I yi by s of x1 comma x1. And it's what? These are constant, xi's are constants. It's summation of 1 x1's I square by s x1 x1 square times variance of yi. Variance of yi is equal to sigma square, right? It's equal to summation of I x1I. So let's rub it off. So what we can get from here is this. Therefore, what we can get from here is the following, is equal to sigma square of this. Observe it's equal to what? Sigma square into sx1 x1 by sx1 x1 whole square. So you get x sigma square by sx1 x1, right? That's the basic idea, right? So therefore you got the variance of it, and therefore what will be the MAC? The MAC of beta 1 hat will be equal to what? Will be equal to bias of beta 1 hat whole square plus variance of beta 1 hat, which is equal to what? What we got the bias? The bias we got as, let's see, we got as beta 2 s, so it's beta 2 square sx1 x2 whole square by sx1 x1 whole square plus this sigma square by s of x1 by x1. Okay, that's a basic idea. That's a MAC. Okay, that's a very easy part. And now, so therefore observe that more is the beta, so it's minimized if beta 2 is equal to 0. So now the food for thought is that, food for thought, FFT, not first Fourier transform, but food for thought. So FFT means that asks you that now compare this MAC with the actual beta naught hat, actual beta 1 hat with respect to the actual model, but not the actual thing. But observe that this MAC, that MAC must be lesser than this, most probably. Okay, count it. So calculate the MAC for the actual model, actual beta 1 hat that you calculate, and then compare it with this, and then compare that which one is more and which one is less. That's the food for thought for you. Okay. Also, I will give you the description of the written part of this problem in our website. And if you like the problem and the solution, don't forget to like, comment, and share with your friends and peers. And see you in the next video. Stay tuned, stay blessed. Bye-bye.